Hello everyone, my name is Ellie Goldberg and I'm excited to be joining all of you across the globe from the smallest state in the United States, Rhode Island. I'm looking forward to becoming a familiar and hopefully friendly face as I bring to you some of the Math Fix tasks and videos this year.
Today's Math Fix is brought to you by G.CO.3, which asks students to describe rotations and reflections that carry onto a given rectangle, parallelogram, trapezoid, or regular polygon. Let's take a look at our problem today. Students need to shade exactly 2 of the 9 smaller squares in our figure to find resulting figures that satisfy the different symmetries listed. Where can we start with this? Diving in with letter A, students may not realize that they must shade in boxes so that there is both horizontal and vertical symmetry, not just one. They may begin by shading in the top left box and realize that although there are some options they could shade in that would have horizontal symmetry, those configurations do not also have vertical symmetry. In order to satisfy both horizontal and vertical symmetry, there are only 2 configurations: the top and bottom middle boxes, or the left and right middle boxes. Part B asks us to shade 2 boxes so that the resulting figure is symmetrical about both diagonal lines of symmetry. Again, students might find configurations that satisfy one diagonal but not both, such as the case where we shade the top middle and left middle boxes. As in Part A, there are only 2 configurations that satisfy both diagonal lines of symmetry. Parts C and D have many solutions. The trick with these is to make sure that the configurations have only the symmetry listed and not others. Here are some possible solutions. The problem gets really interesting when we get to Part E, finding all the configurations where there are no lines of symmetry. One approach students may take would be to draw all possible combinations of shading 2 boxes. For example, they could start by choosing to shade the top left square and then draw all of the remaining possibilities with that square shaded. There are 8 possible combinations here. They may then move on to filling in the middle left square and find the remaining possibilities, realizing that they counted one of the combinations in the last set, so there are now only 7 combinations, and so on. This will help them to double check that they found all possible solutions for Part A through D as well. One extension to this problem might be to have students change the constraints and explore the case where they can only shade 1 box or 3 or 4 boxes and look for any patterns they see.
And there you have it, folks. There are many other ways to approach this problem, and we'd love to hear about those ways. If you've done this problem or plan on doing it soon, please share with us what you've done with this month's Math Fix. Until next time.